see, today's we are going to perform experiment number 5. What is the title of the experiment? See, low pass and high pass filter design using IIR filter. Okay, here we are going to implement the low pass and high pass filter using IIR filter techniques. Okay. I hope in theoretical we have seen many things with this IR filter design. Okay, so here you have different things related to this IR filter. See, we are going to design it with MATLAB, so it will be the requirement for you that MATLAB software is installed on your PC. We are going to utilize a signal processing toolbox. Okay, so that's why here from this MATLAB we are going to utilize the different functions for the design of and analyze of IR filter. Okay, so the signal processing box will be provide you all these things. Okay, here we are going to utilize two things from the signal processing toolbox. Is first one is Chebyshev filter and second one is butter order filter. Okay, so for that Chebyshev as well as butter order filter point of view, here various functions which are present in this signal processing toolbox that we are going to take in our experiments. Okay, now see how you can write the experiments. Okay, for that here I am going over the MATLAB. Okay, see here this is our MATLAB program. Okay, just I am highlighting the first section. Okay, this first section will be designed and written with the help of a Chebyshev low pass filter. Okay, now just understand the code what I written it. Okay, and why this code is written for the getting this response. Okay, so here we are going for the design of IR filter but using Chebyshev techniques. Okay, so that's why this design will require total 4 parameters. What parameters will be required? So we will see in our functions. Okay, so here total 2 functions are required for the design. First function is Cheb1 order and second one is Cheb1. Okay, so that's why these 2 functions will be enough for designing of this problem. Okay, so see one by one what is the meaning of this Cheb1 order function. Just I am opening the help. Okay, from that help I am telling you all these things. See, just I am maximizing the entire screen. See, the name of the function is coming from the signal processing toolbox. Okay, as I told you. Okay, then Chebyshev type first filter order. Okay, so this is the complete name of the filter. Okay, so it requires total 4 parameters. These 4 parameters are WP, WS, RP and RS. Okay, so these 4 parameters are, see, one by one I am telling you about these parameters. WP is a passband corner frequency. Okay, so this passband corner frequency will be needed. Okay, similarly WS is a stopband corner frequency. Okay, so with the help of this passband and stopband corner frequency we are going to design the low pass as well as high pass filter. Okay, now when you are going for the design of low pass filter as well as high pass filter, then for low pass here the technique which is for defining will be like this. See, here we are able to see the filter type is low pass, high pass, band pass and the band stop. Okay, these are the 4 ways for designing. Okay, what will be the conditions will be WP should be less than WS in terms of low pass, as well as here the stop band will be defined WS comma 1 and pass band will be defined 0 comma WP. Okay, this is a way of declaration of this low pass. Similarly, in case if you want to design a high pass filter, then WP should be greater than WS. Okay. Similarly here for showing it for a stop band, it is written 0 comma WS, and for pass band it is written as WP comma 1. Okay, so this is the way of declaration of this low pass and high pass filter. Similarly, the if you are interested in band pass as well as band stop, then the declaration will be looks like this. Okay, now about these two parameters that we have seen. Similarly, again two parameters are there, that is RP. RP is a pass band ripple and RS is a stop band attenuation. Okay, both are defined in decibel. Okay, these are the values. These values are maximum permissible pass band loss in decibel as well as number of decibel the stop band is down for from the pass band. Okay, it is given like this. Okay, so I hope this is about the filter CHEB1 ORD. Okay, now these four parameters are, once you pass these four parameters, you will get the two coefficients from this, that is N and Wn. N will be the order and Wn is a cutoff frequency is getting from this. Okay, now we are going for passing these two values to our Chebyshev filter. So for that, here Chebyshev filter will be defined with the help of Chibi1. Okay, Chibi1 is the name. Okay, just I am again opening the help and I am showing you what is the use of this. Okay, see, I hope screen is seen to you. Okay, here Chibi1 is a Chebyshev type 1 filter using specific object. Okay, so the purpose of this filter is to design the IIR using the specific using the given specifications. Okay, now here the low pass as well as high pass filter you can able to define design. Okay, so here you can pass the parameters. Once you pass the parameters to this filter, okay, N, RP and Wn, okay, then you will get the two coefficient, that is B and A. These two coefficient are representing are enough for finding the poles and magnitude of the filter. So for that, here these B and A coefficients whatever obtained from this Chebyshev filter, that are passed to this frequency name function. This frequency name function will identify the magnitude as well as phase parameters, and this magnitude and phase parameter are separated and they are written under the variable H and W. H represent the magnitude variable and W represent the phase plot variable, right? So out of that, here only the magnitude plot is drawn. Okay, is shown. Okay, in here we are utilizing a subplot concept. Okay, in this subplot concept, 2 by 2 matrix is shown. Okay, and in that 2 by 2 matrix, the Chebyshev low pass filter is represented at first place. Okay, so it is first low pass filter. Okay, and here title as well as X label and Y label is given. Okay, getting this? Now we are going to see the second one. Okay, we are going to see the second one now. Again the same low pass filter concept we are going to adopt, but here the technique is, instead of Chebyshev we are going for the Butterworth filter technology. See, again highlighting again I am highlighting some code here. Okay, this code is related to the Butterworth low pass filter. Okay, again here WP, WS, RP and RS are used. The technology is same, only the function will be changed. Now here the buttered name function is used here. Okay, again we go over the help, we see what is the use of this buttered from this signal processing toolbox. Okay, buttered means butterword, filter, order and cutoff frequency. Okay, it helps you to find the order of the filter and the cutoff frequency. The order of the filter is represented by n and the cutoff frequency is represented by wn. Okay, so it is written in square bracket because here we are going to collect the multiple variable. Square bracket itself indicate a multiple variable declaration. If you are not going to collect a multiple variable, then only n will be written, only wn will be written. But now here n and wn are the resultant from the buttered, so that's why it is kept in square bracket. Okay, then here is equal to buttered name is written along with the all four parameters. Okay, you can able to pass all these four parameters. Okay, again the name of wp, ws, rp and rs will be same. Okay, here again the same filter type is shown here. The same concept will be design concept will be shown here for the pass band and stop band conditions. Okay, the wp should be less than ws and wp should be greater than ws for the low pass and high pass filter. So this will be the way, okay, for declaration for this buttered name function. But buttered name function is only resulting you the order of the filter and cutoff frequency. But now these two things we are going to pass to the butter name. Okay, that butter name function, this butter name function is again, okay, I am just opening again butter name function. Okay, see, this butter name function is very similar to the Chibishu. Okay, here the purpose of this to obtain the Butterworth IIR filter design using a specific object. Here it required some parameters. Okay, these two parameters are passed to this function n and wn, and from this it will do the separation between the b and a coefficients. Okay, b and a coefficients are enough for determination of the magnitude and phase plot. So for that point of view, here b and a are passed to the frequency name function as I said you earlier. Okay, and from this you will get the h and w. H is related to the magnitude and w is related to the phase. Okay, now here again subplot concept is adopted. 2 by 2 matrix is used here, and in that matrix third place is given to this low pass filter. Okay, in earlier it was first place and now it is third place because after Chibishu low, here you will get the Chibishu Butterworth low pass filter graph. Okay, so you can plot it with the help of a plot name function in bracket abs of h, and label, title as well as, okay, label and title is given to the graph. Okay, I hope you got the idea about this Butterworth low pass filter. Now the same concept we are utilizing for the high pass filter. Only see what the difference will be there, that I am just highlighting here. Now first I am highlighting the entire code for the Chibishu high pass filter. Now the same concept is adopted, only the condition that I shown you in the function. Okay, that condition I adopted here. Okay, WP is 0.7, WS is 0.5, RP is 1 and RS is 30. Okay, here what condition I need? Okay, here see, in a low pass filter and high pass filter comparison, okay, I am just comparing with buttered and Chibishu. Okay, here if you observe WP is 0.5 and WS is 0.7. Okay, but in terms of this is about the low pass filter. Now I am talking about the high pass. I am highlighting this value. See, I did a revert value. WP is now instead of 0.5 it is 0.7 and WS is 0.5 instead of 0.7. Okay, just I did the reverted values. Getting the idea? And the ripple. Okay, ripple and RS. Okay, pass band ripple and stop band ripple will be also kept nearly same. Okay, 1 and 30. Okay. So here, once you pass these parameters, okay, to this chill one board, one order filter, okay, you will get the n and wn, that is order of the filter and cutoff frequency. Then pass this parameter to this chibi1 filter function. Okay, this chibi1 function will be written with three parameter, okay, n, rp and wn. But now here one fourth parameter is added to do the identification between the low pass and high pass filter. I hope this is just a name shown here. Okay, it is not necessary to write a low pass and high pass, but for your understanding I kept it. Okay, because here it is an extra way for writing. Okay, so that's why for a user or as those who are beginners in this MATLAB world, okay, for that point of view here I written it in this way. Okay, but the WP and WS value are enough for your understanding to do the difference between the low pass and high pass filter. Okay, but now you are first time you are just watching in the MATLAB, so that's why I did this identification. Okay, once you pass this parameter to this chibi1 function, you will get a coefficient b and a. These coefficient are enough for understanding the poles and zeros. Okay, as well as magnitude as well as phase plot. Okay, so this frequency name function is used for did the finding the magnitude as phase plot. Okay, so h and w got as a resultant. Okay, now here we are going to plot it over the 2 to 2. Okay, subplot is named as second place as a higher order filter point of view. Then absolute plot is taken for this magnitude. Okay, and then x label and y label and title is given to this filter. Okay, now I think the same thing I am just repeating again for the Butterworth. Okay, so for Butterworth point of view here, again WP, WS, RP and RS same values I define. Then again buttered name function is used with the four parameters. It results n and wn. Okay, and then after that here butter name function is called with n and wn, and here high is written for your understanding. Okay, it will results you to coefficient b and a. Once you got this coefficient with that frequency range, okay, here we will calculate the magnitude and phase plot. Okay, for that point of view here b and a are passed, you will get a magnitude and phase values, that is h and w, and these values we are utilizing for plotting. Okay, and finally you will get the plot with these things. Okay, so plot name function is used for plotting that magnitude plot. Okay, I hope you got the code, you are able to understand this code. Okay, so I am just running the entire program. Okay, this is the entire program. Okay, I written it in the four parts. Okay, two low pass filter and two high pass filter. So that's why if I run it, you will able to observe the result. Okay, you can see the result. Okay, from this result you itself do the comparison between the Chebyshev as well as the Butterworth filter. If you look the response for the Chebyshev as well as the Butterworth, you can say here the passband carries multiple ripple in terms of Chebyshev filter, but no ripple in terms of Butterworth filter. See, getting the result, a result is in front of you. Similarly, in terms of high pass filter, in terms of passband, there are multiple ripple under the Chebyshev high pass filter, but in terms of Butterworth high pass filter, the response is very flat, very flat. Okay, so that's why this is the beauty of the Butterworth filter. I think in terms of Butterworth filter is most precise and specific as compared to the Chebyshev filter. Okay, so I hope you can do the comparison between this Chebyshev as well as Butterworth, the low pass and high pass filter. So this is about our experiment. I hope everyone is getting the idea about this comparison also, and as well as the design as well as implementation of this Butterworth and Chibishu low pass as well as high pass filter. Okay, so this is about the IIR filter design. Okay, I hope you are doing this side by side over your MATLAB on desktop, on laptop which are installed at your home. So I hope you are doing it. Try to run it. Okay, those who are not having the system, they take the help of your friends, colleagues. Okay, they will help you very better. Okay, and then I hope this will be enough for this practical. Okay, thank you very much just for watching. Okay.